In this video, we show how to secure the analytics backends by implementing HTTPS communications between front and back. It's a simple objective, but several components need to be updated. In a conventional production environment, the analytics data store and the backend are hosted on a dedicated system. The backend communicates with the analytics frontend and its matching technical components, the Web UI plugin on Tomcat. We recommend securing communications between the two components with SSL. For this, we need to execute a number of steps. First, we're going to need an SSL certificate, and you'll need to obtain this from a certificate authority for a production system. However, for the purposes of testing, we're going to show how to generate a self-signed certificate keystore and make it available to the backend. The front and backend configuration files are reconfigured to use the default 8443 HTTPS port. The backend also needs to access the keystore. Finally, we need to configure the analytics action pack so it can use SSL. We have a dedicated configuration action for this purpose, which we're going to describe and then execute. We start with the analytics infrastructure, namely the Web UI plugin on Tomcat and the backend. In our demo, the former is hosted on a Windows Server system and the backend on Windows 10. Our focus is the securing of the communications between the two components. We want them to communicate over HTTPS. An SSL certificate from an authority and an agent must be available to the host. You obtain the certificate and then install it on that system. For our purposes, we're going to create a self-signed certificate. Then we update the two files, namely application.properties for the backend and plugin.properties for the front. We add the HTTPS and certificate information. Finally, we run the analytics configuration action to reconfigure the pack. We start in the Windows 10 system where the backend resides. First, we have to make sure that analytics is working. We use the dedicated service manager. Normally, you would obtain a certificate from a signing authority and load it in the CA certs file. We're merely testing this implementation, and so we use the JDK to generate a self-signed certificate with the obvious limitations that this entails. We navigate to the OpenJDK bin directory where we find the key tool. We use KeyTool to generate a key store that will contain a key. They have assigned passwords and the store has a validity period. We're not going to provide a full lecture on SSL. Simply, we generate a key with an alias. The algorithm is RSA. The key store has a name and password, and the key has a password as well. For the sake of simplicity, we use analytics for everything. KeyTool prompts you for a number of two-letter acronyms for each field, and you can enter anything you want. You're asked to confirm, you type in yes. Your new key store must be copied to the backend directory. You're familiar with analytics configuration and networking. Both back and front ends have configuration files. If you want to use SSL, they need to be updated. We start with the back ends. We update application.properties. You find the SSL section at the bottom of the file. The first line we update is the HTTPS port. We enable it by removing the hash symbol and remove the dot at the end. We uncomment the SSL certificate lines, then add the path to the key store, as well as the password to the store and the key. Remember that we use analytics for both. Regarding the path to the key store, remember that storing the key store in the backend directory is a requirement, and the system will assume that it's there. As a result, we do not specify a path per se, but merely the name of the key store. Entering a path will most likely cause problems. We do the same with the front end. We have to update the Web UI plugin properties file and change a few things. First, we have to point to the HTTPS 8443 port on the back end. If you're using an official certificate, then leave this line commented. The system verifies the certificate to make sure it's authentic. However, if you're using a self-signed certificate, you must bypass authentication. You set the verify to false. Copy the backend API key somewhere. We'll need this when we update the Analytics Action Pack. We've installed the Analytics Action Pack in AWI. We have to update it so that it's able to operate over SSL. We go to the pack and use the configuration action. We execute the top action. This action prompts for new settings and then stores them for use by the other actions. We're prompted for these arguments when we execute. There's also a requirement to populate SMTP settings, although we can manage without this for the time being. A request appears and this is confirmed by the blue notification. We simply open it. Some inputs are required. We set HTTPS and port for the backend URL, set the API key, and indicate the agents and login on the backend. Note the Ignore SSL Issues fields. On the initial test, we recommend setting this to yes, although things work fine even if you leave it set to no. The configuration check confirms that the action was submitted, but that SMTP was not configured, which is fine for now. We can restart analytics. Let's check the Analytics backend log. This is the first place you should go to troubleshoot when Analytics does not restart. You should be receiving meaningful messages as to why things don't work.